Assalamualaikum. My name is Faiz Osman. I'm from Integrated Project Delivery Partner. So our company is actually one of the few technology providers and one of the product and services that we provide is for intelligent energy management system. And how does this actually relate to today's presentation and also kind of forum or conference? Is that I think this morning when Dr. Azhari mentioned about the Energy Efficiency and Conservation Act, and if you follow through the presentation, I believe that recently the government policy and also under the Act, the government has actually separated the energy efficiency and energy sources into two different trusts, which currently are more clear and also more specific. And as mentioned by Dr. Azhari, is that previously the efforts from the government on the energy transformation is actually being mixed between the energy sources and also energy efficiency. Although that energy efficiency has been actually being promoted quite early since the 2000, but I think because of the development of capabilities available of certified managers and auditors, and that's why a lot of industries, especially from the buildings, commercial buildings, factories, prefer to go for renewable energy because it's much easier and because it gets them faster to achieve the government goals. But I think now the government has noticed that as part of the transition for the energy sources to a more mixed kind of energy, they wanted to actually include the energy efficiency in more intensified ways. And that's where we can see now they has actually separated the two. And that's why now in the latest Government Act, they have actually mentioned specifically on energy efficiency. And that's where we came into the picture today to provide an alternative of way to actually how to make sure that the energy management system, energy efficiency can be complied or can be used or can be deployed in much cost-efficient way rather than trying to depend on higher cost of way doing things. So in the energy management system, which is part of the overall act, all related parties, which is complying to the regulation that needs to hire energy manager. Not only that, there are also a lot of other things under the act that the related parties have to also conduct. So one of it is to have a proper energy management system. So a system is like not only just a kind of system by having a product to monitor, but also in terms of the overall infrastructure and also organization, where it includes the management and also the operation and part of also the team who is responsible for the energy monitoring and also auditing. So in this case, they will need to have to establish a commune which is already there in the market. But the problem is always on how to actually do the remaining work, which is on to assess the performance and deliver targets, to develop action plan, then to prepare the reporting and documentation to measure progress. So all of these need tools to help the energy manager, because alone he himself will be overwhelmed, because if we are looking into a small type of facility, that might be doable. But any facilities that are using 1 million kilowatt hours per year is a quite substantial or quite huge facilities. And that's why, although the government is trying to develop more and more energy managers and auditors, but it's not always not enough. And that's why there's always kind of way, that's why the government introduced one of the trusts is to use technology to help the parties or the relevant stakeholders on how to achieve the efficient way of doing energy management system. So this is quite a small one, but if I can enlarge it, like what has been mentioned by Dr. Azari, the government now not only looking on the electricity, they now consider the thermal system as part of the energy as well. This is correct, because I think energy is not purely electrics. It's also coming from the type of boilers, compressors, other things that are supporting the energy. So the definition of energy also now has been widened, and that's why under the Act, it requires not only just to measure electricity, but also to measure the flow, pressure of the thermal system. So this is why now this is much broader in terms of the energy definition, and how does the industry look at it will be now widened. And that's why now we have two types of energy manager, level 1 and level 2, which is on the industry which is using thermal system as part of the overall facility. They will definitely require the energy level 2. And if you can imagine that before this, just to measure electricity alone, it requires a lot of effort, and not many available capability, not having the enough capability to perform it. What else if we have then to measure the thermal system? That will be also a big challenge. So that's why the technology now needs to come into the picture to assist, to make sure that the industries are able to cope and able to manage with the requirement. So just to give some kind of another additional info, aside of the act that was actually introduced by the government and that will be fully enforced next year, so they are also a standards known as ISO 5001, which is fall under the energy management system. So this is another way of the government to introduce for the industry to actually have a proper way to actually conduct the energy monitoring, reporting, and auditing. So in this way, this will have a proper documentation, a proper way of tracking the flow of the data, and also the integrity of the report being produced. So in a way, by having kind of to conduct the process of energy management system, the industry will be able to have the kind of option to really put into a proper effort where they can also apply for ISO 5001 once they have a proper system in place. So just to highlight why I highlighted ISO 5001, because the product that we introduced today is also in compliance to help the parties who are embarking into the energy management system under the Act, and also wanted to comply to the ISO 5001. So how does the technology help? It provides the data, it provides the transparency, and also it provides the measurement before and after, so that it can be tracked. And the traceability is one of the important facts for the ISO to make sure that the reporting are correct. So this is one of the additional things that you can expect when a part of the Act was being used, and also what are the accreditation in the available in the industry that will follow through. So why do we measure? Although that it is required by the government, it's always something that, like Dr. Azri mentioned, before this, as the operation or the people inside the organization, we might know that there are room for improvement that are available. There are opportunities in terms of introducing new way of doing things or introducing new procedure or replacing equipment or trying to replace aging equipment. Those are the things that usually the operation or the technical people will know, but it's always something it's difficult to really convince the management, and sometimes it requires a lot of effort to come to the to change the current existing way of doing things or change the current equipment. But with the new introduction by the Energy Conservation Act, it becomes a top-down, where now it becomes compulsory, and there will be kind of like a inspection or probably kind of auditing by the government. So now, rather than become an operation, it becomes a compulsory kind of action to be taken. And this is something that will support the operation, because at the end of the day, they will help them to find a way to tell that, okay, we have this kind of situation and we need to improve the way of doing things. So this is why how we came to the picture. The goal is that not only to measure energy at the incoming level, meaning that looking at the utility bill or looking at the metering. What we can do, actually, we can measure at the machine level. So sometimes we know that in the factory we have like what, 40, 50 machines running. Usually current auditing, we only look on the total. But since we are going to measure the total energy consumption, why not measure it at the machine level? So that you can see exactly where is actually the usage of energy is coming, and how much energy is being consumed by each of the machine. And in terms of the granularity, you will be even more clear in terms of the duration, in terms of the quality, in terms of the actual condition of the machine. So from there, we can actually use the data for the plant manager to actually identify and plan. And those can be translated not only just to see the machine as consuming the energy, but also in terms of the overall picture of the situation on each of the equipment. So what makes us different with the existing energy auditing or existing way of doing things? So we are not changing something quite abrupt in terms of the way of doing things. Especially in this case, we started off with like electricity. So in our previous project, we do have like a combination of using the existing conventional data locker and our new product where we use a wireless and also without power. So the quite significant difference that we can see is that the amount of time that we take for the audit is much lesser, and the cost that we also require is also a bit more significantly different from others. So that's in terms of the audit. But in terms of the energy management system context, we are looking into a system that can not only monitor to get the baseline, but since in the act that it will require the energy manager to report on the improvement, you will need a data that can show there's an improvement after the changes has been made, either through changes of operation hours or changes in the standard operating procedure of the plant, or by changing the equipment. So the previous issue, the current issues that we have, whenever we do an audit, let's say we conduct an audit, we conduct a baseline, we know what is happening inside the plant or inside the building. And what we do is that we provide recommendation. So after that, it's up to the owners, or the building owners or the plant owners to make a decision whether they wanted to change the equipment or they wanted to do change in their operation hours. But then the changes can be only reflected by the current year. But the actual changes, whether the changes they have made really impact, it doesn't know until they conduct another audit. So that will be kind of way troublesome, because you have to call back the auditor, then conduct another round of doing to monitor. But by having kind of this type of solution, we can see before and after, so that the changes that you make, you can know whether it's impactful or not. So the sensors is quite easy to install. So it's not something that is new. You can see that it's the clamp, it's normal clamp. But the difference is that not only the way the hardware, but also the business model that we approach. So this is just to show how we clamp it and then how we connect it. So there's no power supply required except for the bridge, which is the gateway. And the way we connect it to the clamp that we clamp to the wire, we do not have any connection between the bridge and also the sensor. So it makes it easy to install, and we do not have to leave it on site with a kind of wire going out and in and out from the MSB. So what you can see is that it's very clean. It doesn't require any kind of cabling to connect between the two. So those are the one quite a major difference as compared to our current conventional data logger. So in this case, this is just an outside picture. So that's the first part of the hardware. So on the software part, so basically what we wanted to do is that to give the energy manager a clear picture of what is actually happening. Because if previously the plant or the industry or the factory can depend on the energy manager or energy service company to tell them, okay, you can contact an audit, do analysis, then come back to us to actually tell us what is the current condition. But as now the Act require, and each of the facility require their own energy manager, so this software or this hardware is a tool that the goal is to assist them. Because if you have like thousands of factories or thousands of industries require, each of the plant or each of the factory have to have their own energy manager, and to have the same capability, it will be very difficult. So that's why this is a tool that actually was intended to help the energy manager to have more insight and also to understand what is happening and to know what the areas that can be do for improvement. So this is just one example. So in this case, so we actually take measurement on three different types of compressors.
The sensor only require one unit, or
Each sensor is one equipment.
one unit?
So, and we do not require, it's like a rental. We don't have to actually acquire it. And the rental is very low as compared to the current existing auditing punya way of doing things.
Maximum
Mid- Boleh? Okay. Yeah.
And then only one bridge.
Oh.
Sensor, one bridge can collect data.
Yeah, this is like a router. Actually, they are dedicated only to connect between the sensor and also the bridge. So from this bridge, it's actually connect to the internet local Wi-Fi or to the SIM card. How much sensor per bridge? I have to check, but I haven't put in lama dah install. My team has already installed. Nanti I just check. Tak ingat berapa per bridge.
What's the city rating maximum?
City rating?
Maximum.
It can do up to 1000 amp. Yeah.
So one sensor to one bridge only.
No, one bridge can actually connect to multiple sensor.
What is the maximum that can connect to?
That's why the same question. I will check my engineer after this. Let you know.
As long as the bridge can
Connect distance.
the connection distance.
Because your connection is only one, right?
No. This one we have multiple. Either we use Wi-Fi or using it.
Based on the previous project, so we claim for the chiller room, so 4 unit and 2 AC. So still we need one. But the all unit must be in the installation temperature.
But your this is a wireless, right? So
Yeah.
any limitations? Because in a plant, maybe there's overcage or
Yes. So the main problem is the connection. Wi-Fi connection. But even though we already installed in the ground floor of the building, so but we need to adjust the connection of the building.
so the software will be installed locally.
The software.
The software is on the website.
On the web.
Web based. Yeah.
Means that I need to access only I will link up.
Yeah, because it's this is a service based. Means you only, let's say you want to let's say for 6 months or 1 year. It's a subscription based. You don't have to own it. We just provide you the service, and then you just access it. So very minimal kind of infrastructure required. You can go to the website of principal. So there's actually they provide the pricing over there. So you definitely see where it's quite low lah in terms of the rental, the prices. Ada kat belakang tu ada contoh. You can see that. Yeah.
So your CD is a stroke file.
Stroke file.
This one you said mention 1000
MP.
over 5 meg.
Over file. Yeah.
Over 5 meg over 1.
Dia terus dia motor.
The ratio is let's say over 5 meg over what's the
Based on the thing is 5%.
So actually currently we have project before. So we actually significantly reduce from 3 months to 1 month. So the audit, because we can measure multiple locations. So that actually reduce the cost.
So what's the length of the cable?
Length of the cable, actually I have a
Standard one.
standard one. So this is a clamp. So this is a clamp usually. So what we do is that here we connect it to this connector, and this connector then will communicate with the bridge wirelessly. So this actually helps a lot in terms of data collection. So what we put is usually we put in the MSB, we close it back. So there's no wire coming out, in and out. So in the maintenance operation, we will not know something is actually being collected.
Do you have this more accuracy class, this is class 1?
Yeah.
You have like 5 class
0.5, I can check with the manufacturer, the principal. Okay, so in this case, the dashboard is just to show that, let's say, so the advantage is that not only you can measure energy, but you can see the whole pattern, the energy consumed by the machine. So as an energy manager, you have a better picture of, let's say you have 20 machines in your plant. So which are the machines which actually consuming a lot of energy, and then they can actually help you to analyze what is happening currently in your factory. Let's say currently you have 3 compressors, but in the 3 compressor, there are some compressors is actually working outside hours, which is probably one of the issues where the energy being consumed. And that's where we can actually tell them, okay, why do you require this? They will tell, the system will tell the energy manager, have the energy manager to look back in the SOP or the operation where they can actually reduce the cost and also reduce the energy. So in this case, yang ni simple lah. This one quite simple. Some. Yeah. Sebelumnya. So basically they are monitoring 3 compressors. So they are actually, when they monitor the compressor, so somehow the compressor, they exhibit some energy consumption outside peak hours. Maksudnya during outside operating hours, they are compressor running. Yeah, so they were asking why this compressor is running outside operation hours. So is it because of probably ada leak ataupun there's actually other people working, maybe? So basically we clean each of the compressor. Every minute they collect data. Yeah. Oh, tak ada every minute. Tapi ini the graph is actually dia dah expanded lah. X-axis X-axis time. So the energy. This one kilowatt. This is kilowatt. This is time. So mungkin ada something is happening or that during the night, maybe people unloading equipment or some additional working hours. So you can justify lah why this is happening. So in this case, simple thing lah. Someone forgot to turn off the fan. So they say that, okay, why is the fan still off, still using power at night, although the factory is not operating at that time. So it's just a matter of, by right, usually as a human, as normal way, we do practice, turn off the light, turn on the light, turn off when you don't use it. But sometimes maybe forgotten, it become a habit, so the system can detect. So in this case, if you want to have a line, production line, and you want to calculate the energy price per product, this is also available lah. So just to say that when you measure, you are not only measuring to comply to the Energy Conservation Act, but you will also, the energy manager will have an insight of a better, much better, because he will have a more in-depth knowledge or your overall picture of what is going on for each of the equipment or what is going on in the operation. In this case, they wanted to see how much energy per price per product if they say they have multiple lines, and which product has actually higher cost. So sometimes because for them to factor in, okay, we are producing this kind of product and this volume, how much the energy for that product is being consumed actually, not in terms of the overall, but per line. Means that you can go per the line. If let's say this line is producing this product, so what is the actual energy cost for that line? Means that you can target individual rather than the whole plant. So in this case, they wanted to know whether should they turn the machine at the right time. Sometimes, as we know, an operation, because you have one technician to go all around the place. So rather than waiting for the operation hours to start, they always start it early because they have to go to many locations. Sometimes it's too early and you start to consume energy. So in this case, they are showing that okay, the dryer is turned on quite early before the operation start. So that's where we probably have to change a bit to say that okay, rather than you start too early, maybe start it much later. So just skip this one. This one is more like a machine comparison. Let's say, like I mentioned before, you have like a two line, and this two line is on the same product or the same way of doing things. But this new line, you want to change to a new machine. So how do you know that actually by converting the new machine can actually save you energy? So this is one way to actually to monitor and compare whether the change of the equipment or change of doing things does really save your energy, or is it the same? So this is kind of good way to provide the energy manager or the operation data to tell tell the operation, to tell the management, which is that there are impacts when you do upgrades or you do change of way doing things. That's really give the change to the overall picture. So other than electricity, we also monitor compressed air. So as part of our collaboration today with TurboWind, we wanted to make sure that we can support them by ensuring that we are able to provide a better insight of the use of compressed air. Because compressed air plays a lot as well, plays a bigger role, especially when it's related to boiler. And now boiler is also part of the thermal system, which is also part of the overall Energy Conservation Act, which requires the factories or industry who use thermal system to be also doing the auditing and monitoring. So not only we are participating in terms of helping the clients to know what is the situation, but by having kind of the similar system, we can also help the client to see if they what is the current situation, and if they make changes, will that be any further improvement to their overall thermal system and also energy usage. So these are the three key items that we measure. First one is airflow, in terms of the flow patterns, the volume over time, and also the compressor efficiency. And at the same time, pressure. Because we noticed that sometimes there are some factories only measure based on pressure. They see the pressure is okay, then they assume the compressor is okay. But in terms of the overall efficiency, they did not get the bigger picture because the data was not available. As long for them, as long the pressure is okay, then that means compressor is okay. But by having to monitor airflow, pressure, and temperature, you will need, then you have a better insight, and also it's much more more specific on what would be the current condition that the compressor is operating in. So this is kind of data that we collect. Let's just keep this one. So they have a client. They actually have 5 compressors, and these 5 compressors is actually consuming a lot of electricity. So they require kind of way to measure whether they want to know the compressor is doing well or how they behaving. So and they need us to actually monitor the air consumption patterns, see whether there's actually how does the compressor is behaving, and if there's any leakages, because we know that sometimes if there's any leakage in the line, then the actually compressor might be serving the leak rather than the actual operation. So rather than looking at the machine alone, what we are looking to be more precise, to know what is happening, not for the machine alone, but for the operation as well. And then that's where we actually come up with a kind of recommendation. So they are able to identify that actually the compressor is operating. One of the reasons is because there's a leak, and at the same time to look into the schedule to optimize the use of compressor and to revise the piping system to more efficient flow. So this is a types of advices or type of insight that is important, because under the Act it's not only for electricity but also for the compressed air. So this is the actual dashboard. You can actually see the compressed airflow. You will see the pressure and also the temperature on real time. And this is like a report to show that how much is this compressed air consumption per month. This is from Multicube. This is more. So when you have the compressed air and then you have the electricity, you can then correlate between the efficiency of the compressor system with the electricity. So from there you can have an overall view. So what will be the efficiency of the system, not only the efficiency of the equipment for maintenance purpose, but to support under the Act for the energy consumption. Okay, so that's all. Do you have any questions?
How do you got the flow inside the nest?
We have to do a hot tapping, or we do a meter. Yes. So we either use this one, we hot tap the line, so we actually install the sensor outside, or we get transmitted at this one.
So how you link to your software?
The same what we're using, that is the bridge.
So you have your flow meter.
Yeah, flow meter, but it's a wireless flow meter. Yeah. This one. Yeah. Pressure, yes.
You want to call an endpoint or after the pressure?
Uh,
Only install
This one dekat ada sini endpoint kot.
Maybe specifically must use this book.
Doesn't require, but because we need the connection between the bridge and also the flow meter. So we try to use as much as we can minimal type of infrastructure to make sure that it's easy to install. Okay. So, any other questions?
Apa PT je?
Huh?
Ada PT kan? Kita mau
Ah.
cost.
Oh, the cost here. Usually we go like they say lah, if you're going for long-term monitoring or audit, depending lah. Kalau katakan for audit, kita take it only 1 month, kita tengok untuk tengok pattern lah. Yeah. Okay. Anything else?